Hello students, today we will start. The next topic is framing in the data link layer. Here the group of physical layer bit stream into the units or some messages is called as the frames. Breaking the bit stream into frames is called as a framing. Here the data link layer translate the physical layers raw bit stream into the discrete units is called as the frame. How can frame be transmitted so the receiver can detect frame boundaries? That is, how can receiver recognize the start and end of the frames? Here the some physical layers accept raw bit which is not guaranteed to be error free and attempt it to be deliver it to the destination. So it is the responsibility of data link layer to detect errors such as the number of bits received may be less or contains different values, etc. Here the one method to achieve these framings is to insert time gaps between frames. But this method is not useful because network rarely may guarantee about the timings. So that these gaps might be squeezed or other gaps might be inserted during the transmission. So other methods have been devised. Here there are the some methods for framing. First one is the character count. Second one is flag byte with byte stuffing. Third is starting and ending flag with byte stuffing and encoding violations. These are the physical layer coding violations. First method is character count. Character count method uses a field in the header to specify the number of characters in the frame. The data link layer at destination check the character count is known how the many characters follows and where the end of frame. Here the first method framing uses field in the header to specify the number of characters. Then when the data link layer at the destination sees the character count, it known how many characters follow, hence where the end of the frame is. Show this figure. Here shows the 4 frame of size 5, 5, 8 and 8. These characters respectively. See, this is the figure, and in this figures character counts. First one is the 5. Here start the characters 1, 2, 3, 4 and 5th. This is the character 5th. That's why this is 5 characters. Then second is also character count is 5. That's why here the second character count is 5 and this is the frame number second. Then it adds the characters from starting to end 1 to 9, 0 to 9s. Then here the 6, 7, 8, 9. This is the 4 and 5 is 5. That means this is the 5th character. Here the 5th, then second is 5th. Then third character is 8. So count is also 8. Then here the 8, insert this third character count 8 and start 0, 1, 2, 3, 4, 5, 6 up to the just 8 number. Here 0 to 6, this 7 and 8 is 8th number. So that's why this is the 8 character count. Then third is 8 character. Then start here the 6, then start from 7, 8, 9. When 9 is here, then start with from first letter 0. So here the 7, 8, 9 and 0, 1, 2, 3 up to. But here character count is 8. That's why here these are the 7 and 8 is 8th character. That's why this including 8, these are the 8 character count. Here that's why this is the character and these are the 4 frame. First frame is 5, second is 5, third is 8 and fourth is 8. These are the 8 frame. First one is frame 1, 5 character. Second one is the frame 2, 5 character. And frame 3 is 8 character and frame 4 is also 8 character. These are the 5, 5, 8, 8 character counts. And these are the single character 0 to 9. Then second frame is here. It contains errors. This second B is the error Here is suppose this is the frame 1. Here suppose first character count is 5, 1 2 3 4 and 5. This is the correct. But second frame, this frame is 7 and it contains 6 7 8 9. This is the wrong. That means there the frame 2 is the error. Then these errors, then third frame is started from 0 and now this is the character count. Here just simple the character count means this fields header to specify the number of character in the frame. This is the main concept for character count. Here the header specify the number of character. Then second method is flag byte with byte stuffing. Here the stuffing means included. Stuffing means just included the bytes. This second method's framing method is the flag byte. It solves the problem of resynchronization. Every frame starts and ends with a special bit pattern is called as the flag byte. Here uses reserve character to indicate the start and end of the frame. For instance, use two character sequence DLE STX, that means data link escape, and start of the text. STX means start of text to signal the beginning of the frame, and the sequence DLE, that means data escape, data link escape and end of the text to flag the frame ends. And the second framing method, starting and ending character stuffing, get around the problem of resynchronization after an error by having each frame start with the ASCII character sequence and end of the sequence with the DLE ETX. See the figures. Here this is the first example, DLE STX. This is the A and B. Then add the DLE STX after the characters. Then add the DLE. Then add before the character DLE ETX. This is the then second time. This is the stuff, that means just add or include. And second one is the original data. That's here the concept is add the stuffing bytes, and at the time of sending and at the time of receiving it can receive original data. See one another example here. This is the suppose original message A flag A. Concept is add the escape, here the escaping, that's why add the escape characters at the before the flag. That's why here the A flag A, add the escape sequence before the flag. See, this is the here the original sequence and adding the escape before the flag. Then second sequence is A escape A. At the time of escape, concept is also same, add the escape before the character. That's why here the add escape before this escape. Then second is at when escape and flag both appears at the same times, then what to do? Then it also add the escape before the escape and add the escape before the flag. That means here this is the escape adding and this is the escape adding before the flag. That's why here the two escape adding, here this escape before and before the flag, two escape added here. Is here another example is when two escapes appear at the same times, then what to do? Then add these two escape before the this escape. That means here this escape and this escape are the original escape, but add then second escape. Here this is the first escape and this is the second escape. That's why here the four escapes added in this original messages. Here this is also second representations for byte stuffing and unstuffings. That means here the flag data from the upper layer. Then stuffs means simples include. Then frame send, this is the flag, this is the header sections and add the escape before the flag. at similar before examples we have already seen. Just here the graphical representations for the stuffing, and this is the this second escape is added after the escape. Then from at the receiving time this flag is generated, here the first escape and here the adding second escape. But when actually receiver side this message will be reach, then original message will be received, and this stuff adding byte will be unstuff, and original message, this is the original message from the sender side, and this is the original message from the receiver side. That means add these bytes and remove the bytes, that means unstuff. Then third method is starting and ending flag with bit stuffing. Here it allows character code with an arbitrary number of bits per character. Each frame begins and ends with a special bit pattern. In this example, we have take a special bit patterns 0, 111, 111, 0. In fact, a flag byte, whenever the sender data link encounter 5 consecutive ones in the data, it automatically stuff a 0 bit into a outgoing bit stream. Here this is the logic for starting and ending flag with the bit stuffing. That means when 5 consecutive one appear in the data, then we can add a 0 bit into this bit stream. This is the just logic for the starting and ending flags with bit stuffing. Here one of the example, these are the 5 consecutive one, that's why we have added the 1 bit. Here this is the bit stuffing and unstuffing. Suppose we have provided this data, this is the original data, data from the upper layer. We have a rule. Rule is our just add when in the data link layer encounter a 5 consecutive one in the data, then we can automatically stuff the 0 bit into the outgoing bit stream. That's why here the first 3 zeros, then second time this can appear once, and when 5 ones appear at the same times, then we can add the 0. That's why here add the 0. Then second time here the 1, then 0 0, but here this is also 5 ones, that's why we can add 1 0. Then remaining data same we can write. Then here the second times, at the time of receiving, frame will be look like this. This 0 and this 0 we can add it as per rule. And when unstuffing or when the receiver side, it automatically 0 can be disappear and original data will be displayed. When a receiver sees 5 consecutive 1 followed by the 0 bit, it automatically destuff the 0 bit. And if the user data contains a flag pattern 0, 111, 111, 0, this is transmitted as the 0, 111, 0, then 5 times 1, then 0, 1 0, but stored in the receiver memory as the 0, 111, 111, 0. This is called as the starting and ending flag with the bit stuffing. Then physical layer coding violations. This is mainly used for network in which the encoding contains some redundancy. Some LANs encode 1 bit by using 2 physical bits. 1 bit is high-low pair and 0 bit is the low-high pair. Every bit has a transmission in the middle, so it is easier to receive the locate the bit boundaries. This framing method is used only those network in which encoding on the physical medium contains some redundancy. This scheme means that every data bit has a transition in the middle, making it easy for the receiver to locate the bit boundaries. The combinations of high and low are not used for the data, but the used for delimiting frames in some protocols. Here the one of the examples, like we have already seen Manchester encoding, differential Manchester coding, and binary coding. These are the suppose this is the data provided, we have provided, and binary coding is look like this. When 1, then here the signal, then when 0, then signals at the down positions. Then in the Manchester encoding, these are the 1 for this graph and 0 for this graph, and in the differential Manchesters we have already seen. Then third type is error control. Error control is one start and end of the frame is detected, and the next problem is how to make sure that all frames sent by the sender and deliver to the network layer of the destinations and in the proper order. If the sender just keep outputting frames without bothering whether they are received or not, retransmissions occurs many times and bandwidth is also wasted. Here, error controls is concerned with ensuring that all frames are eventually delivered, possible in order to destinations. Then how? Then three items are required. First one is the acknowledgement. Typically, reliable delivery achieved using the acknowledgement with a retransmission paradigm, whereby the receiver returns a special acknowledgement frame to the sender indicating the correct receipt of a frame. In some system, the receiver also return a negative acknowledgement for incorrect received frames. This is not nothing more than hint to the sender so that it can transmit a frame right away without waiting for the timer to expire. Second item required is timer. One problem that simple acknowledged scheme failed to address the recovering from other frames. That means the data frame that is lost and result fails to solicit the acknowledgement. What happens in acknowledgement becomes lost. Retransmission timers are used to resend the frame that don't produce an acknowledgement when sending a frame schedule a timer to expire at some time after the acknowledgement have been written. And third one is the sequence number. Retransmissions introduce the possibility of duplicate frames. To support the duplicate, add sequence number of each frame so that a receiver can distinguish between new frames and old copies. And fourth type is flow control. Consider a situation, sender is running on fast computer and receive is running on the slow computer. The sender keeps on sending frame at high speed, but receiver is not able to accept it. After some time, a receiver is totally swamped out, and even though the transmission line is error free, at a certain point the receiver will be unable to handle frames and start losing them. To prevent such a type of situation, flow control is used by data link layer, and these are the two different flow control mechanisms. Are first one is the feedback based flow control and second is the rate based flow control. In the feedback based flow control, the receiver send back information to the sender, giving it permission to send more data, or at least telling the sender how the receiver is doing. And second is a rate based flow control. In the rate based flow control, the protocol has a built-in mechanism that limits the rate at which sender may transmit the data without using feedback from the receiver.